Hello and welcome back to the development of the Feersum scheme compiler. So in the last stream we were working on fixing a bug, I think. Just gonna go and check the history, find out. Yeah, I think we were working on the rewrite captured locals in lower. So I'll just go over what the problem was there and what the solution was. So we had an example spec for it, which was self capture. The problem we had was the way that our capture, conversion, and rewrite was working was being too eager with it wasn't properly getting rid of the local variable. So when we have the outer function foo and the inner function bar has two separate local variables. Foo has two separate local variables, bar and baz. Because bar captures itself, it gets lifted up into the environment. We were ending up with a captured value in the environment, and then we were also ending up with the local still in foo's locals. So this is the captures, this is the locals for foo. Initially, foo had two locals, local 0 and local 1. Bar had a capture for foo's local 0 and a local of the arg0, which is the x. And after the lower, initially, this was still local 0, local 1, but no one was referencing local 0 anymore. So the change that we made was in the lower. So the way that lower works now is when we rewrite the environment, when we calculate the mappings, we call find captured, which is what we always used to do, where we basically go through and find everything. So in this case, we found local 0. We'd move local 0 to become environment 0. And the way we do that is by creating a mapping from storage ref to storage ref. So we'd say, if you see local 0, rewrite it as environment 0. We've also then done this second step where we then go and find everything. We find all of the locals as well as, so we don't look, and then we get the difference between the locals and the captured. So that's anything that is in the locals that isn't captured. And then we rewrite all of those. So they're the remaining locals. We rewrite those to brand new indices. So that means that we can compact things back down, and we end up with a case where this local 0 is effectively this local 1 that's been shuffled down a bit. So with that out of the way, I think a good place to start is we've actually got our first pull request for this. Raw coding on Twitch has implemented or ported over one of the specs from another one of our programming languages. So this new spec GCD defines a modulus function, and GCD, which gets the a common divisor between two numbers, and then just a bunch of tests for that and the appropriate snapshots. I'm happy with this, so I'm just going to squash it down. I think this is Hacktoberfest. I think this one wants to be, this issue wants to be closed as well now. So on to the plan for today then. We've got support now with, well, I guess the first thing to do would be to show off support for the templating. So let me just get a new terminal. So .NET New has support for installable template packs. So if I do not .NET New, we now have this Feersum templates. Oh, I messed up that copy and paste. So this Feersum templates, if I do, it's now on the README. You can do .NET New install Feersum templates star, and this will get you the latest template pack. And then with the template pack, there are now new list dash list. There's now new templates for the language scheme. So these templates scmlib, classlib, and console, which means that we can test or scheme example. Now if we change into scheme example, I can now do .NET New console language scheme. And run it with a new project. So we've got a program.scm file and we've got a project file. So now I can do .NET run and that will get compiled and run. So that should make making new projects a lot easier. We can also, I get rid of everything. I can also do .NET New classlib language scheme, and we've now got a standard library that's not output type exe. So I can do .NET build, but in this case .NET run won't work because the output type is not an executable. So the plan for today is just a simple change to introduce a new library so that we can start writing more of the scheme standard library. At the moment, we don't really implement a huge amount of the scheme standard library, so it's not actually that useful of a programming language. But hopefully, we're at the point where we can start to actually write some of the standard library in Scheme itself. So currently we have a folder, we have the main compiler, we have an SDK, a template pack, and we have Shrifa, which is our like core library. And this contains things like conspair, and it contains C# code that exposes some of the Scheme base library. So for example, the character functions here and stuff to do with the idents. We have the actual ident class itself, and then we have the symbols method, so things like is symbol and that kind of stuff. For a lot of these, we don't actually need and it would actually be better if we didn't write them all in C#, because it would be easier to write it in Scheme. So it would be nice if we could build a core library in Scheme itself. So what I'm going to do is I'm going to start off with not a new file, a new folder. Feersum dot. I think we want it to be Feersum. Feersum.core. This is going to be the thing that we will end up linking to from the final executables rather than Sreefa. Well, actually, we'll probably just link to both of them. So using that template pack I've just showed you, we can start stubbing out a project. And then we want to make a few changes. So we want this to be built using the compiler that we've got locally. I'm trying to decide whether or not the whole of this. Yeah, so we kind of want to, we want to share what's happening here in the examples. So I think we could do with extracting that into a props file somewhere. And eng is usually what this is called, or at least it is in Microsoft repos. And then inside here we can have local compiler props. Well, then we can take, I think, pretty much everything here. So we want the language targets. We want the property group that disables implicit Feersum core. Stubbing out the compiler configuration. Do we use that? Or oh yeah, that's for deciding which compiler to run. Yeah, and we just want to take all of those, put them over here. And this then needs to import project is eng local. Let's call it use local compiler dot props. That makes more sense. And I'm going to copy this name. Let's just build that. So with any luck, that should still build. It does, and then we can go to our project for our standard library, and we can do the same thing. Wants to go up one more level to get the compiler props file, and then I think that might work. Just deciding whether or not it's best to change this over to use the plain .NET SDK. If we're going to be importing those projects, the props files might be best to just set it like this, because then you'll be able to build from scratch. Otherwise, you'll be depending on the output of a previous build. And we're not even testing that at the moment because I've not added it to the solution. .NET SLN add dot. Now does it still build? No. Unknown language detected. Yeah. So this is Git version not playing very nicely. We set Git version right at the root. So how do we disable Git version? Oh, it's just implicitly, because all of these examples just use this directory build props. So I think there's a few options in Git version that you can tell it not to, because the problem here is Git version's not able to. The Git version tool, stepping back a bit, the Git version tool will run and look at your source tree and then works out what the semantic version is at the point in the tree. And on a F# project or a C# project, it will then generate a file, git version.json, which contains all of the version information. And depending on where you're compiling for, debug or release, it will also generate a git version information, like in this case we're F#, so this is the FS file, which basically is a type that's got a bunch of metadata on it. But the error that we're getting is to do with Git version not knowing how to produce one for the language scheme. And that is because in Feersum core, we're importing lose local compiler, and use local compiler will eventually end up going through to the SDK targets file, which conditionally sets the language to scheme. So I think we might be able to get away with, like, let's have a quick look at what Git version does. So somewhere in here, there is a props file. I've been here before. Nope. No. Git version ms build. So somewhere in here. No, that's the ms build tasks. Build. Build props. Yeah, I think. Nope. This is it. So we have generate assembly info. Generate file version attribute. So we want to set update assembly info to false, I think. And that might just be enough. A lot of things seem to be predicated on that. I would still quite like it, Git version to run, because I would quite like the resulting the version number to be available to MS Build, so that when we do pack and stuff like that, the project will be packed correctly. It's not fixed it completely. Trying to work out from this stack trace whereabouts it is. Git version tasks. Well, what else is there that we can disable? A new project file is generated. Doesn't sound like it. Generate Git version information. I mean, we can try. Maybe it's this. The file I just showed. What was it called? Git version information. Probably that. Nice. So we've ended up with something that's built, at least. So, and if I do a .NET pack, you should hopefully end up with a package that's versioned reasonably well. artifacts, we have Feersum core, not been to beta, which let's just sync, and then we'll check out new branch. And this one wants to be scheme core, I guess. So just as an exercise to prove that we can start using this, the plan is to try and implement this, the CXR library. So in our Lisp library, we already have car and CUDA, which for accessing the address and data, the left and right hand part of a pair. So if I go to lists, we have cons list, make list, and we also have car CUDA. So with these two implemented in C#, we can actually write the rest of the library in Scheme. So that's the plan. So let's go back to lib.scm. No, that's not that one. Lib in core. And let's rename it to CXR. And we need to update this as well. So we actually need to define two separate libraries here. So we're going to define scheme can define scheme base. Let's define scheme base, import scheme base. That doesn't sound like that's going to work. Let's do scheme CXR for the time being. We may need to come up with a new name for all of the stuff that's in the Feersum library at the moment, because otherwise we're not going to be able to overwrite. We're not going to be able to implement part of a library in one .NET assembly and part of it in another. So I think the solution there is to have like a core library and define that all in one place, and then re-export everything back into the scheme base library. So we have like define library scheme base in this Feersum core, and we'd import and then re-export everything. So scheme, is it scheme CXR? I've lost it already. Pairs and lists. Yes, CXR library. And I think all of these library names are prefixed with scheme when they are referenced. So basically, I think we can just copy this. Come on. We can just copy this code block, paste that in there, and that's the first part done. And then we need to do an export declaration. I think we just list them, don't we? CDAR and CDDR. And just to test this out, let's go and try and write a spec for this. And define test list. and we'll just quote a bunch of numbers. So we need it to be a few levels deep to be able to get this. So we need to be able to do 2 levels for this. So we can do like 1, 2, 3, 4, 5, 6. Then we can do display, and then we want to test each one of them. CAAR. Test list. CADR, CDAR, and then CDDR. So the AA should be 1. AD should be a list containing those 2. And then D is going to be this, and then A would be 4. And then D would be 5, 6. I think. Would it? Or no, because D would be 4, 5, 6, 7, 8, 9, and then D again would be just a list containing the list 7, 8, 9. So I think that should work. The problem here is if I do run spec CXR, it's going to fail to compile because we don't have the import. CA blah blah blah. So I think a quick fix to this would be in our spec tests. If we go to the tests, we can do .NET add reference. To the core. And then in compile example, we can add it to the references. So where do we... So we have a list, I think, of references that we add. Yeah. So we can just... Oh, this is a feature that's actually coming in C#6, I think. That you'll, sorry, F#6, you'll be able to indent, you won't have to indent this closing brace. So we can do type of, we don't know the name of anything in that library yet. Let's see. We can just ILSpy and find out. List types in spec, not spec, source Feersum core bin Feersum core. Dear Jesus, what's going on here? Fearsome core. Okay. Does that just need rebuilding? Fearsome core. Feels like, yeah, there we go. This looks a lot more like it. It's got a lot more stuff in there. So we've got fearsome.core.lisp program. That'll be something that will just always be there. Actually, we can just do fearsome core.lisp program dot. We want module assembly, because we want to do this in targets. Yeah, just .assembly.location. What's this complaining about? It is given an explicit type argument. I think you're just out of date. Good. So if I try and run that spec again, will it find our library declaration? Nope. What has gone wrong here? I know what it is. Run spec is actually completely different. We want to add a reference in here as well. Reference core dot yeah, Feersum core bin and all that. But it's going to be .core. Never type what you can copy and paste. Interesting. Bin. So Feersum core bin release net 5. Just build the whole thing. I think it might just be that the build hasn't run. Things are taking more time, but that's probably just because it's because the build hasn't run. Well, I'm seeing less output and fewer errors than I was expecting there. Did it fail? Yes. Which bit failed? .NET. Let's try running the whole thing. Well, actually, let's see. What would it have created? Spec bin is going to be spec bin cxr.exe. Why aren't we generating a runtime config file? We should generate a runtime config file. We should do that in compile. Oh, it's because we've not compiled it as an executable. Is it? No, the output type is XC. So it's... Do I want to debug this or do I want to just printf it? Just got to printf it. String. I just want printf. What have I done wrong here? Hopefully this should fail. Oh, it's not. Could not load file or assembly. That's awkward. We need to copy the result to the output directory as well. I think we can do this in... Let's try running the tests and see whether or not they do a better job of it than the run spec. Just a second. And I'm back. So the tests have failed, which is unfortunate. We've got 2 failed because snapshot does not exist, which compile and run for debug and release. So if we do update snapshots, what do we end up with? So I think we're just going to end up with like some kind of stack trace. Compile and run. Yeah. I guess for now we can put the same hack in. We get read. If we get rid of this hack, you won't just be able to compile things anymore. We probably want to have think about that anyway. So we shouldn't really be generating this runtime config file ourselves either. So we shouldn't be copying the stuff to the output directory. So we need a better way of dealing with this. I think for the time being, let's move the copy into the test. So compile and run does parse directives, exe path, compile file, and then it does run example. So I think compile file. Run example probably wants to take references now. So the first thing we're going to do is the copy that we've just taken away from compile. We take the exe path. Get path. Can we get a directory name? I need to tell it that exe path is a string. There we go. So yeah, we can copy the core path, and we can also then do, well, I guess we want to do references. Seek dot append. Core path. It and then we'll just do this for all of them. So that means that if we've added any extra references, we'll copy them to the output directory as well. That path. Now we stand a chance. Which two have failed? Okay, so display utils. Ugh. Okay, special case here. So yes, we want to say if. So we'll say let out the equals. We'll extract this. So we only need to do that once. And then we can say if path get directory name on the thing we're copying is not the same as the out there. And that is this. We can just run the test now because the snapshot should be up to date. And things looking pretty positive. Let's try it. Run spec should now work for us because everything's already in the output directory and no copying is required. Cannot load file or assembly. Feersum core. Oh, yes, because we'll just make run spec do this. We'll do CP. It's called out there. Out. Spec bin. Oh, I just want it to be spec bin, don't we? And we can copy the Shreefer as well. Now, this is one that I always typo, so I'm going to find it. Come on. Surely this time. There's no such file or directory. Because it's .NET Standard. Nice. So, CXR. We're looking at CAAR, which is 1, which is because it's the first element of the first list. Then we've got CADR, which should be the first element of the second list. No. Yeah, yes. So D would be this, and then the first element of that is the list 4, 5, 6. So it is then 2, 3, which is the tail of the first element, and then D, which is the list containing just this bit. Looks good. So let's go through and review what we've done. We've got a new project added to the solution. We've got changes to run spec so that we copy the output. We've got the new use local compiler props file and the changes to the build props to deal with that. We've got new project reference to the core from the test so that we can reference its type and copy it in places. we've got the new spec that tests the CXR. We've got changes to remove some of the hacks from the compiler. We've got the new library to define the 4 procedures. We've got the place where all of the library copying has been moved to in the tests. We've got the new parse results, and we've got the output for the specs itself. So I'm happy with that. So it's time to add Feersum core project. This project will contain the pure scheme, should be capitalized there. There are still plenty of hacks going on here. There definitely are. I think that's it for today. So thanks for watching, and I will see you next time.